So for another hybrid model, we've already seen the health economics model, so I don't want to go into that again. But I did want to ask you to download a model which is available on the site. And this model is going to be one that's, I think, in the hybrid folder here. Just looking here, right. There's actually two. So one is called Environmental Contamination Hybrid. I'd like you to load that one. It's in the hybrid folder of the AnyLogic 7 examples. And it's called Environmental Contamination Hybrid. Do you see that? It's under AnyLogic 7 examples, hybrid models.
Oh, hybrid models. Sorry.
Yeah. Okay. Do you see that?
Yeah.
Okay. So I'd like you to open that up, and I'm just going to give you a very brief look at that. So again, hybrid models, and it's called environmental contamination. Now this model basically depicts a situation where we have persons who are in one of several health states. If you go look at person, they have an infection state chart, which is pretty familiar. They're susceptible, they're shedding, or they're recovered. And you'll note that they can get infected, ladies and gentlemen, via the environment, through its exposure to the environment. They also have a state chart that takes them between work and home, throughout the day, okay, and across days. Now, within this context, both the home and the workplace are associated with pathogen reservoirs that can build up, ladies and gentlemen, over time. So these build up as a result of shedding by agents who are infected. So in short, there's a pathogen reservoir at the workplace, and for each person around there who's infected, effective or shedding, in the shedding state, those persons will be shedding into this pathogen reservoir, and then there's some level of pathogen die-out. It's kind of associated with some half-life of pathogen inactivation. But this mean pathogen lifetime is a little bit different from that by a factor of natural log of 2. But its point is there's some pathogen that dies out in the workplace. And same thing at home. So the idea here is that people are going to bring the pathogen from home to work to home. And if one person starts infected, over time, they will bring it back and forth between their homes and their workplaces. So I'm going to add population at first so that we can run this in a tractable time here. But I'll run it for small population here. Okay, it's the last one. And I think one person starts infected here, and they're going to start shedding to the environment. And people aren't going to get the bug directly from that person. They're going to actually get it from the environment. Looks like this is, I see, yeah, so this only spreads for a brief time. Maybe we'll want to try the medium-small population. Let's try that. Medium-small population. So one person, I think, starts infected in this model. People go back and forth between home. And you'll notice that these, can you see this? Ladies and gentlemen, I'll slow it down. But you can see that there are these pathogen reservoirs, and each of these squares is colored according to the pathogen level at that location.
Yeah, the house.
And as that pathogen builds up, the person's chance of becoming infected who's at that location becomes higher. And if we go to person, we'll find that the environmental infection route here is based on a current exposure level times some coefficient. So in short, these highly contaminated workplaces serve as kind of a point where pathogen can spread to other people, and then they can bring it home back to their home. So like here's a home with 2 people infected, right? And they're bringing it to each of their workplaces. Okay, this is actually another home. They probably got it through a workplace. And going back and forth to the workplaces serve as kind of this conduits of infection to additional homes. This workplace is badly hit. People bring it home, spreads to their spouse, other family members who bring it to yet other locations. And through all of this, there are not only people infected, but there's also, ladies and gentlemen, these workplaces. So we can go down to workplaces here, and we can, for example, here the workplaces get pathogen built up. This is probably during the day. And then it may decay for a few hours at night, and then it builds up the next day as people are exposing it again, and it decays. And we see this kind of alternation between these periods where it's empty and no shedding is going on, and where it's shedders being present. So this is a model with, it's an agent-based model, yes. We have people, we have workplaces, we have homes, but within those agents are dynamics characterized using stocks and flows. Do you see that? So we have stocks and flows characterizing the continuous dynamics associated with these facilities. And that's a very convenient way to describe the continuous dynamics with respect to continuous quantities, like the level of pathogen reservoir, the level of a pathogen in a reservoir. Now I'd like to show you another model that has similar characteristics. Any questions about this model before I go into another one that also leverages this idea but uses it for regulatory pathways in addition to just continuous dynamics? Okay, so let's go to the to these models I provided, and there's a model called CTL state variable. Okay, this is cytotoxic T lymphocyte state variable. Use any logic 7. It's also in the hybrid models area. Okay, CTL state variable. Use any logic 7. Okay, I'd like you to download that. Okay, so this would be